Today I want to find the derivatives of sin of x and cos of x. In fact, I actually want to find the derivative of something of this form, where x has a certain frequency and b is a shift. So we just use the standard definition of a derivative. So sin over h. And then let's distribute the a. Next, I want to use the sum angle identity. If you watch one of my previous videos, I proved that sine alpha this equals and the angle we're going to split here is I want this in this what do you call it? Oh yeah, in this argument here, I want this to be alpha and this to be beta. I want to split these two angles. So if this is alpha, then the formula would be sine ax plus b cos ah plus cos ax plus b. Oh yeah, I'm just switching this around with that. Sine ah, yeah. Minus, don't forget that, sine all over h. Now I want to see the sine ax plus b here. I want to factor this out from this term and from this term. So we bring this over to here and we factor it out. We get something like this. Sine ax plus b. And when this is factored out, this just becomes -1. So we get cos ah minus 1 plus. And since this is a fraction, I'm just going to separate this term from that term. So we get two different fractions here. All over h. This is sine ah, by the way. Now, what does the limit of, I'm just going to go to a new page. What does this equal? In one of my previous videos, we discovered that the lim of h approaches 0 of cos sine of h minus 1 over h equals 0. Now, here's what we can do with this. We can multiply a on both the numerator and the denominator. So we get cos h minus 1 over h equal a over a times h, and we get this. Over ah, and we can set ah to equal y, some random y. It doesn't matter what variable you use here. And as the lim as h approaches to 0, y also approaches 0. So basically we can rewrite this as lim y approaches to 0, a times cos y minus 1 over y, and we can factor this out. And look, this formula right here is really similar to this formula. In fact, it's almost identical. So we can just say this just equals 0. So then we just get this equals to a times 0 equals 0. So here's our final result. This thing right here equals 0. All right. Now let's tear out this page. What about here? What is the limit of lim as h approaches 0 sine ah over h? Well, you'll see that this looks really similar to this. Equal 1. And I proved this in my previous video. So we're going to do the same method here. So sine ah over h equal a times sine ah over ah. And we set y equal to ah, lim as h approaches 0, y approaches to 0. So we get a sine y over y, lim y approaches 0. You factor out the a, and this is very similar to this. So this just equals a times 1 equal a. Now, so we know this term right here just equals 0. So in effect, we just get sine ax plus b times 0. Because look here, this equals 0, this equals this times 0. All right. And we know that sine ah over h just equals to a. So we get this times a. And finally, the derivative of sine of ax plus b equals a cos ax plus b. And if you know the chain rule, you know why this a is here. And let's say a equal 1 and b equals 0. If there's no shift and the frequency is just, well, 1, then this would be a equal 1, then that's just x, and b equals 0. So 1x plus 0 is just sine of x. And a equal 1, that's 1 times, well, cos of x. So the derivative of sine of x is cos of x. Now, what about for cos of x? Well, let's find the derivative of this, and I'm going to do it real quickly. And oh, it's raining outside. We factor out cos ax plus b to get this. Minus 1, all right, for h, minus over h. Well, as we said before, this just equals 0. and this just equals a. Finally, we get the derivative of cos of ax plus b is negative a sine ax plus b. And if a equal 1 and b equals 0, then cos of x would just equal the derivative of cos of x is just negative sine of x. Alright, here's the full proof. And this is the proof of the sine and cos things. Alright.